All right, so we're going to practice the chain rule. And basically you've been doing it the whole time, or we've modified stuff so you wouldn't have to do it. But I'm just going to show you an example of what it is. If we've had something like 3x plus 2 and we squared it, and I asked you to take a derivative. Well, what we did then is that we FOILed this out. So 3x plus 2 times 3x plus 2 would have given us 9x squared plus 12x plus 4. Okay? And then we would have taken a derivative, which would have given us an 18x plus 12. Now, if the derivative of the inside of something, so it can be the inside of parentheses, it can be the inside of a denominator, it can be the inside of a numerator, it can be the inside of a radical, it can be the inside of pretty much anything. If the derivative of the inside is not 1, then you're going to have to use the chain rule unless you handle it through algebra some other way. So that being said, this is not chain rule. What we did was simplify algebraically and then took a derivative. What I'm going to do now is show you chain rule. So let's just pretend I got this chunk raised to the second power. Do I know how to take that derivative? Yes, I do. I'm going to drop the 2 out front, times what's sitting there, which is what I've been doing, drop my exponent by 1, so this is now to a first power. The difference is I'm now going to multiply my answer times the derivative of the inside. So what's the derivative of the inside? It is 3. So now I have times 3. So 2 times 3 is 6 times 3x plus 2. And then when I distribute that, I get 18x plus 12, which is what I got on the other one. So chain rule is simply finishing it out by saying times the derivative of the inside. Now when I say that stuff, what does that mean? Because like up here, when we were doing stuff with product rule and with whatever, the derivative of the inside was always 1. Okay, it was always 1. So by multiplying by 1, you don't change what it is. So now we're just kind of sort of tweaking it just a little bit. So we are going to practice by using chain rule and deciding when it's appropriate and when it's hard and all that kind of good stuff. So for instance, if I have a 7 minus 3, that is such a lie. I have a 7 minus x to the third. Okay, I have a 7 minus x to the third. So for you to determine if you need to use chain rule, your question is going to be, is the derivative of the inside 1? And your answer on this one is no, because the derivative of the inside is negative 1. So we're going to have to use chain rule. So your bigger picture is I got this chunk raised to the third power. Okay, so I'm going to drop that exponent out front, times what's sitting there, and drop my exponent by 1. The new part is times the derivative of the inside. So the derivative of the inside of this one is negative 1. So I'm just going to make negative 1 times 3 is negative 3. Okay, so that's the new part, times the derivative of the inside. So remember to keep your bigger picture in mind. So I've got multiplication on this one. So I've got t to the 6th minus 3 to the 5th. So I see my bigger picture is this thing times this thing. But you don't have to use product rule. You do not have variables times variables. So this is just a coefficient. Okay, so this is just one big fat term, and I'm going to use the chain rule because the derivative of the inside is not 1. So I'm going to drop my 5 out front and get a 10. T to the 6th minus 3 raised to the 4th. So I just did power rule because I'm dealing with the powers. Okay, so I did power rule. Now what's the difference? Times the derivative of the inside. So the derivative of just the inside is 6t to the 5th. So now I have times 6t to the 5th. Okay, and that is chain rule. So let's try it again. I have 7t squared minus 6t, and then plus 2. And I'm going to take that raised to the 3/2 power. So again, do I have to use chain rule? Yes, because the derivative of the inside is not just 1. So I'm going to have to use chain rule. So start off, drop your power out front. So I have 3/2 times what's sitting there. Don't change this. Drop your exponent by 1. And now times the derivative of the inside, which will give me a 14t minus 6. And that's your derivative. Okay? So it's going to take a little bit to get used to. Just remember you've been doing it the whole time, or we've adjusted. Okay? So let's practice again. I have the square root of 4t squared minus 1. Now, immediately, I don't like how it's written because math people cannot manipulate this symbol. So remember, I'm going to make that a 4t squared minus 1 to the 1/2 power, because this whole thing is to the first power, but I'm taking a square root. So now, do I have to use chain rule? Yes, because the derivative of the inside is not 1. So drop your exponent out front times what's sitting there. Drop your exponent by 1. And now times the derivative of the inside, which is going to be 8t. And you could clean this up because half of 8 is 4. Okay? So half of 8 is 4. So you could rewrite this as a 4t times 4t squared minus 1 to the negative 1 half. Because half of 8 is 4. And there's your t. Okay? Let's try it again. So I have the square root of 7x squared minus 4x plus 6. I'm going to rewrite that as 7x squared minus 4x plus 6 to the positive 1/2 power. And now I'm going to use the chain rule. So drop your 1/2 out front times what's sitting there. Drop your exponent by 1. And then, what's the new part? Times the derivative of the inside. So the derivative of the inside is a 14x minus 4. And again, you could take half of this. You can't take half of that because it's trapped inside of a radical. But you can take half of this and make that a 2x minus 2 if you wanted. Okay? If you wanted. So let's keep going. I might get to squish this into one video. All right, so I'm going to find the derivative of each function. For the first function, we have 9x squared minus 2x plus 8. And for the second function, we have the square root of 9x squared minus 2x plus 8, which I'm immediately going to rewrite. So the question simply says, take this derivative, take that derivative. Okay, so it's a two-step problem. So I'm going to rewrite this one as 9x squared minus 2x plus 8 to the positive 1/2 power. So now, what is this one's derivative? This is just f prime, that has a prime, is 18x minus 2. Okay, 18x minus 2. This one, g prime of x, is going to become 1/2 times what's sitting there. Drop your exponent by 1. And then times the derivative of the inside. So that's why they had you do this first step. Okay. So let's try it again. So I have 7 over the cubed root of 3t squared plus t. Okay, so we had one like this in an earlier section, and this is why I was screaming, yelling, and hollering. We couldn't do quotient rule on it. It was similar to this, but it wasn't just like this. I'm going to go back and find it in a second. All right, so what's the first thing I notice? The first thing I notice is I cannot manipulate this radical. So I'm going to rewrite this as 3t squared plus t to the 1/3 power. All of that's raised to the first, but I'm taking a cubed root. Well, now I need it to be up top with a 7. So now it becomes 7 times 3t squared plus t to the negative 1/3. So you have not done calculus yet. All you've done is rewrite. This is one term. 7's job is just coming along for the ride. And so now I can drop my negative 1/3 out front because I'm actually going to take a derivative now. So negative 7/3, 3t squared plus t to the negative 4/3. Okay, and then times the derivative of the inside. So the derivative of the inside is a 6t plus 1. 6t plus 1. And then you're done. All right, so let's do another one. We have 6t to the 3rd plus 2t squared minus 6t plus 6 to the negative 3 power. Okay, so can I use, or do I have to use chain rule? Yes, because that's your inside. Its derivative is absolutely not 1. Okay, so drop your negative 3 out front times what's sitting there. Drop your exponent by 1, so he goes to a negative 4. Now times the derivative of the inside. So I get 18t squared plus 4t minus 6. Someday I'm going to learn to start writing on this side of the paper. Okay, so you can do that one. All right, so let's, honestly, well, I'll just go ahead and do it real quick. All right, so we have one more like this, and then I'm going to go to a second video. So I've got g of t equals 8t minus 9 to the 4th plus, and then I've got 8t plus 9 to the 4th. Okay, so these are not like terms because one is a positive, one's a negative, so you can't put them together. But I can go a term at a time. So my first one, drop your 4 out front. Drop your exponent by 1, and then times the derivative of the inside means times 8, which means you could make that a 32. Okay, same thing. So this will be a 32, 8t minus 9 to the 3rd. Same thing. Drop my 4 out front, times what's sitting there, drop my exponent by 1, and then times the derivative of the inside. And then 4 times 8 is 32. Okay, so we'll finish this section up in the last video.